Aquatic ice means water ice. Friends, you should know that water is present everywhere, in the sea, in the mud, and up in the sky. And wherever there is water, ice is also formed due to coldness. You know, friends, mostly snow is famous in the northern hemisphere and southern hemisphere of our earth. By the way, ice also melts due to increase in temperature. Friends, you should know that maintaining snow is important for some countries of our earth. Well, a very unique system has been used by NASA to freeze ice. What is NASA's arrangement for the stability of ice? Once they collect the ice cores, some are put into a pressure chamber under vacuum to remove all the media modern air and are then melted. The gas from the ancient bubble is released as the ice core melt and then gets carefully pulled into sample canisters which are about the size of a SCUBA tank. Near the end of this field campaign, the term will pull everything out to waiting helicopters using a big pink shield to wait behind their skydoo. The team will fly the ancient gases extracted from the ice cores to McMurdo station before heading back to the University of Rochester Petrenko lab. The Scripps Institute of Oceanography Severing Laboratory and the Oregon State University Ice Core and Quaternary Geochemistry Lab. The skydoo will eventually hitch a ride from the helicopter as well in a sling load dangling from a big wire cable tethered to the bottom of the helicopter. Antarctica is a really emotional place. Rup said it's a rare opportunity to go where people don't live. Where people can't live, this is the age of where humans should be. There's no trash, no animal tracks, no power lines, not even a bird. Nothing to give you skill. It's like the exhilaration of breaking a rule, poking a boundary, and there's something thrilling about that. The National Science Foundation has a precedented mandate to manage the US Antarctic program, under which it supports researchers coordinates all US signs on the southernmost continent and in the surrounding ocean and provides the infrastructure and logistical support needed to make the science possible. Find out more about the University of Rochester Ice Core Expedition here. Thank you for reading, Laura. What did NASA find under the ice? Scientists using NASA's Earth observing system find evidence of phytoplankton blooms hidden beneath Antarctic sea ice. Until now, researchers believed the packed sea ice of the Southern Ocean, also known as the Antarctic Ocean, blocked all light from reaching the sea beneath. Warming seas and melting ice sheets. We know this from basic physics. When water heats up, it expands. So when the ocean warms, sea level rises. When ice is exposed to heat, it melts. And when ice on land melts and water runs into the ocean, sea level rises. For thousands of years, sea level has remained relatively stable and human communities have settled along the planet's coastline. But now our seas are rising. Globally, sea level has risen about 8 inches since the beginning of the 20th century and more than 2 inches in the last 20 years alone. All signs suggest that this rise is accelerating, while NASA and other agencies continue to monitor the warming of the ocean and changes to the planet's land masses. The biggest concern is what will happen to the ancient ice sheets covering Greenland and Antarctica, which continue to send out alerts that a warming planet is affecting their stability. We have seen from the paleoclimates record that sea level rise of as much as 10 feet in a century or two is possible if the ice sheets fall apart rapidly, said Tom Wagner, the Cryosphere program scientist at NASA headquarters in Washington. We are seeing evidence that the ice sheets are waking up, but we need to understand them better before we can say we are in a new era of rapid ice loss. The structure of ice, McFarlane Ronald. Abstract: the stability of the high pressure ice forms discovered by Tamman and Bridgman at very low temperatures and atmospheric pressure has made it possible to obtain X-ray diffraction photograph of this form. Since ice is extracted from the base by taking it through the ice region, the precaution taken to avoid consequent misinterpretation of the ice films are given. The analysis of the ice diffraction pattern leads to a body-centered orthorhombic structure and a until unit cell of dimensions A is equal to 10.20 A, B is equal to 5.87 A and C is equal to 7.17 A. The unit cell contains 16 molecules, has the symmetry of space group page 26 1 pm and leads to a value for the density of 1.105 G per cc. Each oxygen ion is surrounded by a distorted tetrahedron of oxygen ions in a manner similar to that of ice. An arrangement of the hydrogen atoms is proposed which makes the ice 3 ionic. The volume decrease in the ice 1, ice 3 transition is shown to be the result of a rearrangement of the oxygen ion. A simple transition mechanism is described which is used to interpret some of the phenomena observed by Bridgman. The nature of the ice 2, ice 3 transition is also discussed. A correlation between the latent heat of the solid reactions involving ice 1, ice 2, ice 3 and the HOH bond angle is suggested. Some remarks are made concerning the liquid-solid reaction at high pressure. A brief description of some qualitative results obtained from the unanalyzed ice B and ice B1 film is made a summary of all the conclusion drawn from the high pressure ice investigations is made. Publication, the Journal of Chemical Physics, Volume 4, Issue 4, B 253 to 259, pub date April 1936, DO1 10.1063 by 1.1749832. BIP code 1936 JCHBH 4253M. Why did NASA drill ice in the South Pole? The thick, uncontaminated layers of ice there will help answer questions about how Antarctic climate interacts with the rest of the world. The period between 40,000 years ago and 10,000 years ago includes sudden swing in temperature, ending with warming at the end of the last ice age, 20 January 2015. Frozen water, snow seen in soil, is in both hemispheres, ice and the ice. Is in both hemispheres, ice only ice. Frozen water, snow seen in soil, is in both hemispheres, is in the ice. Is in both hemispheres, ice only ice. Southern hemisphere, water, water. Northern hemisphere, soily rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Southern hemisphere, water, water. Northern hemisphere, soil or rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Frozen water, snow seen in soil, is in both hemispheres, ice only ice. Is in both hemispheres, ice only ice. Frozen water, snow seen in soil, is in both hemispheres, ice only ice. Is in both hemispheres, ice only ice. And there are clouds in the air, atmosphere of snow even in the clouds. Falling clouds weaken rain. Snowfall drop by drop water. Snowfall drop by drop water. And there are clouds in the air. Atmosphere of snow even in the clouds. Falling clouds become rain. Snowfall drop by drop water. Snowfall drop by drop water. Frozen water, snow seen in soil, is in both hemispheres, ice only ice. Is in both hemispheres, ice only ice. Frozen water, snow seen in soil, is in both hemispheres, ice only ice. Is in both hemispheres, ice only ice. This topic, like water ice, this aquatic ice is present in our world. It is because of this aquatic ice that the terrestrial surface of our earth is very safe to a great extent. Otherwise, our earth would have been completely covered in water long ago. However, sometimes due to the warming of our earth, a considerable part of the land level goes into the ocean home. You probably know, friend, that the very famous empire of Hindus, Dwarka Sea, was conceived centuries ago. Where did the Dwarka Empire reside? Dwarka. Wikipedia. HTTPS in Wikipedia organization Wiki Dwarka. Considered the original residence of Krishna. Bet Dwarka was the old port during the ancient times of Krishna before the Okha port was developed in Dwarka. Jam Sri Ravalji, head of Jadeja clan Rajput Kshatriya, migrated from Kutch to Halar, established himself and set his throne at Khambhalia in BS 1582. For some years, it was his capital and new city in BS 1596 named Navinagar. Jam Khambhalia is the headquarters of the newly created firm Devbhumi Dwarka district, which was carved out of Jamnagar district on 15th August 2013. The district considers 4 talukas: Khambhalia, Kalyanpur, Dwarka and Vanves. The name Devbhumi Dwarka is derived from the famous Dwarkadish temple of Dwarka city, which is one of the 4 holy places according to Hindu mythology. Dwarka is believed to have been the first capital of Gujarat. The city's name literally means the gateway to heaven. In Sanskrit, as Dwar means gate and Ka references Brahma. Dwarka has also been referred to throughout its history as Maksapur. Dwarkamat and Dwarkavati, it is mentioned in the ancient prehistoric epic period of the Mahabharata. According to legend, Krishna settled here after he defeated and killed his uncle Kamsa at Mathura. This mythological account of Krishna's migration of Dwarka from Mathura is closely associated with the culture of Gujarat. Krishna is also said to have reclaimed 12 yojanas or 96 square kilometer, 37 square mil of land from the sea to create Dwarka. Dwarka was established as the capital in Saurashtra by the Aryans during the Purana. The Yadavas, who had migrated from Mathura, established their kingdom here when the city was known as Kaushatyali. It was during this period that the city underwent rebuilding and was named Dwarka. Friendly population of natives also prompted Krishna to settle at Dwarka when he decided. After fighting Jarasandha, the king of Magad, to retreat from Mathura, the kingdom also known as the Yaduvamshi Empire was established by Ugrasena, father of Kangsha, the then rule, and later Krishna flourished and extended its dominance. Is said that Krishna conducted the administration of his kingdom from Dwarka while residing with his family in Bet Dwarka. The city's Dwarkadhish temple dedicated to Krishna was originally built around 2500 years ago, but was destroyed by Mahmud Begeda rules and subsequently rebuilt in the 16th century. The temple is also the location of Dwarka Matha, also called Swarada Matha, Peeth and Western Peeth, one of the four Peeth Sanskrit religious center established by Adi Shankaracharya. As an important pilgrimage center for Hindus, Dwarka has several notable temples, including Rukmini Devi Temple, Gomti Ghat, and Bet Dwarka. There is also a lighthouse at the land and point of Dwarka. Archaeological investigation at Dwarka, both on shore and offshore in the Arabian Sea, have been performed by the Archaeological Survey of India. The first investigations carried out on land in 1963 revealed many artifacts. Excavations done at two sites on the seaward side of Dwarka brought to light submerged settlements, a large stone built jetty and triangular stone anchors with 3 holes. The settlements are in the form of exterior and interior walls and 4 basins. From the typological classification of the anchors, it is inferred that Dwarka had flourished as a port during the period of the Middle Kingdoms of India. Coastal erosion was probably the cause of the destruction of what was an ancient port. Where is the original Dwarka? The mystery behind the lost city of Dwarka, Savari Car. The initial excavations began about 100 years ago in the 1930s around the island of Bet Dwarka, located approximately 30 kilometers north of modern day Dwarka in Gujarat, Jamnagar district. More excavations were carried out in the 1960s, but no definitive results were obtained. 6 February 2023. Where is Dwarka, where Krishna lives? According to legend, Krishna settled here after he defeated and killed his uncle Kangsha at Mathura. This mythological account of Krishna's migration to Dwarka from Mathura is closely associated with the culture of Gujarat. This was captured in the old Dwarka palace or the empire sea with the passage of many years. Perhaps due to such heat at that time, the sea ice did not melt. But these days, we are facing this problem. The snow chain is troubling us a lot these days. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Water is liquid. Water is smoke. Water turning into rock like ice. Water turning into rock like ice. Water is liquid. Water is smoke. Water turning into rock like ice. Water turning into rock like ice. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Snowfall ever fell from the clouds. When snow formed in the sky. When snow formed in the sky. Rain drops with the snowfall. Snowfall everywhere is slowly. Snowfall everywhere is slowly. Raindrop with snowfall. Snowfall everywhere is slowly. Snowfall everywhere is slowly. Snowfall even fell from the clouds. Oh, in snow formed in the sky. Oh, in snow formed in the sky. Snowfall ever fell from the cloud. Oh, in snow formed in the sky. Oh, in snow formed in the sky. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Water is liquid. Water is smoke. Water turning in rock like ice. Oh, water turning in rock like ice. Water is liquid. Water is smoke. Water turning in rock like ice. Water turning in rock like ice. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Friends, do you know that sometimes a piece of ice, like a small stone, starts falling along with a drop of water? What we Bengalis call stone pelting. Friends, we Bengalis feel very surprised to see this rain of stone. Snowfall means snowfall, meaning small snowflakes falling from the sky. Friends, why do we Bengalis feel surprised? I am telling you. We understand that water falls from the sky in the shape of a drop because there are rivers in our Bengal. We are familiar with many waterfalls. We have seen drops of water falling from above. But this ice in small pieces, how can it be? Why does snow fall from the sky in small pieces along with the rain? If the cloud is colder, such as it would be at higher altitude, the water droplets may freeze and form ice. These ice crystals fall to earth as snow, sleet or rain, depending on the temperature within the cloud and at the earth's surface. Why does snow fall from the sky? Snow is precipitation that forms when water vapor freezes. When the temperature drops below zero and there is sufficient moisture in the air, snow falls in the form of ice crystals from the clouds. What is the process of water and ice falling from the sky called? As water is released from clouds in the form of rain, snow or hail, it is called precipitation. What are the snowflakes that fall from clouds like rain? Rain may start as water droplets or ice crystals in a cloud but always falls as liquid water, balls of ice that fall from clouds and can even dent cars and called hail. Hail is formed in thunder cloud. How is snow rain called? Hail. Frozen rain or ice pellets that fall as rain from clouds are called hail. What is water falling from the sky in the form of rain, hail or snow? Rainfall and water cycle, US Geological Survey. Precipitation. Precipitation is water released from clouds in the form of freezing rain, sleet, snow or hail. Precipitation is the main way atmospheric water returns to the earth's surface. Most of the precipitation falls in the form of rain. 8 September 2019. How does snowfall occur? How is ice made? Made of fish. Snow is formed when small ice crystals in clouds stick together and form snowflakes. If enough crystals stick together, they will become heavy enough to fall to the ground. Snowflakes that descend through moist air that is slightly warmer than 0 degree centigrade will melt around the edges and stick together to form larger pieces. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Water is liquid. Water is small. Water turning into rock like ice. Water turning into rock like ice. Water is liquid. Water is smoke. Water turning into rock like ice. Water turning into rock like ice. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Snowfall ever fell from the clouds. When snow formed in the sky. When snow formed in the sky. Rain drop with the snowfall. Snowfall everywhere is slowly. Snowfall everywhere is slowly. Raindrop with snowfall. Snowfall everywhere is slowly. Snowfall everywhere is slowly. Snowfall even fell from the cloud. Oh, in snow formed in the sky. Oh, in snow formed in the sky. Snowfall ever fell from the cloud. Oh, in snow formed in the sky. Oh, in snow formed in the sky. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Water is liquid. Water is smoke. Water turning the rock like ice. Oh, water turning the rock like ice. Water is liquid. Water is smoke. Water turning into rock like ice. Water turning into rock like ice. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Chain of ice in the water in the sky. This is the solid state of water. This is the solid state of water. Frozen water, snow seen in soil, is in both hemispheres, eyes and the eyes. Is in both hemispheres, eyes only eyes. Frozen water, snow seen in soil, is in both hemispheres, is in the eyes. Is in both hemispheres, eyes only eyes. Southern hemisphere, water. Northern hemisphere, soily rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Southern hemisphere, water. Northern hemisphere, soil or rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Frozen water, snow seen in soil, is in both hemispheres, eyes only eyes. Is in both hemispheres, eyes only eyes. Frozen water, snow seen in soil, is in both hemispheres, eyes only eyes. is in both hemisphere, eyes on the eyes. And there are clouds in the air, atmosphere of snow even in the clouds. Falling clouds became rain, snowfall drop by drop of water, snowfall drop by drop of water. And there are clouds in the air, atmosphere of snow even in the clouds. Falling clouds become rain, snowfall drop by drop of water, snowfall drop by drop of water. Frozen water, snow seen in soil, is in both hemisphere, eyes only eyes. Is in both hemisphere, eyes only eyes. Frozen water, snow seen in soil, is in both hemisphere, eyes only eyes. Is in both hemisphere, eyes only eyes. It is true that due to low temperature in the southern hemisphere and northern hemisphere, there are more snow chains. But while the clouds always face the sun, so how can a cloud become icy? The moisture in clouds must become heavy enough to succumb to gravity and return to Earth's surface. This occurs through two processes. In cold clouds, ice crystals and water droplets exist side by side. Due to an imbalance of water vapor pressure, the water droplets transfer to the ice crystal. West Texas A&M University, https wtamu.edu C. Belt 2013 12-13. How can there be clouds in winter when it is too cold for water to stay a vapor? Category Earth Science, published December 13, 2013. Clouds, public domain image, source Christopher S. Baird. First of all, clouds are never made out of water vapor. Water vapor is invisible because its molecules are too far apart to optically scatter light. Whenever you see steam, mist, fog or cloud, you are seeing small drops of liquid water or crystals of ice and not water vapor. The water drops or ice crystals in the air are usually too small for you to see them individually. So instead you see a white or grey haze. For instance, with every breath you exhale, you are blowing out water vapor that has evaporated from your lungs. You don't usually see your breath because the vapor you exhale stays in the gas state. But when the air outside is cold enough, the water vapor you breathe out quickly condenses to little drops of liquid water and you see your breath as a small coot. Secondly, clouds are not always drops of liquid water. Clouds can also be composed of ice crystals. In fact, the same cloud can be partly composed of water drops and partly composed of ice crystal. Clouds have no problem existing in the cold of winter because they can just exist as ice crystal. In fact, even in the summer, some of the clouds you see are composed of ice crystal. A lot of the rain drops we experience in the summer started their existence high in the sky as snow flakes but melted before reaching us. When the water drops get high enough in the sky, they encounter the colder temperatures at higher altitude and freeze. Even in the summer, both water drops and ice crystals in a cloud are so small that they both look like white fluffy fluff from the ground. You usually can't tell the difference between a water cloud and an ice cloud just by looking at it. But there is a difference. Water drops are mostly spherical while ice is crystalline with flat surface. This difference in shape means that the types of bows they create are different. Water droplets in the air create rainbow, while ice crystals create sun dogs, halos, and earth. Thirdly, water can exist as a liquid in water, even below its freezing point. If there are no nucleation centers, sub-freezing liquid water is called super cooled water. In order for liquid water to condense to a solid, it has to be cold enough and have somewhere to freeze onto. All it takes is a bit of dust or even vibrations to kick start crystallization. But in certain situations in the atmosphere, such nucleation centers are sometimes hard to come by. As a result, the water can stay liquid below freezing temperature. Lastly, even when the air near the ground is at freezing temperatures in the winter, there are still open layers of atmosphere higher up that are warm enough for water to stay liquid. Topic: atmosphere, clouds, condensation, freezing, frozen ice, supercooled water, weather, winter. What causes ice to cloud? The natural atmosphere. Indeed, the spontaneous, homogeneous nucleation of an ice crystal from pure water droplets of 5 required temperatures below minus 38 degrees centigrade. Mineral dust, metallic particles and biological material are the best known ice nuclei to date and contribute to the formation of ice cloud. Water wave. Smoke rises, to the sky. But why is the eye still? Water repels, smoke rises, ice is stable. How to see falling is snow. Ice is stable. How to see falling is snow. Water repels, smoke rises, ice is stable. How to see falling is snow. Ice is stable. How to see falling is snow. There is no water below, water above the sky. Difference between the two, water and precipitation water. Difference between the two, water and precipitation water. There is no water below, water above the sky. Difference between the two, water and precipitation water. Difference between the two, water and precipitation water. Water repels, smoke is rises. Ice is stable. How to see falling is snow. Ice is stable. How to see falling is snow. Water repels, smoke is rises. Ice is stable. How to see falling is snow. Ice is stable. How to see falling is snow. Earth's atmosphere, what is plasma light? Ice in water, smoke and snow in the sky too. Ice in the water, smoke and snow in the sky too. Earth's atmosphere, water is plasma light. Ice in water, smoke and snow in the sky too. Ice in water, smoke and snow in the sky too. Water repels, smoke rises. Ice is stable. How to see falling is snow. Ice is stable. How to see falling is snow. Water repels, smoke rises. Ice is stable. How to see falling is snow. Ice is stable. How to see falling is snow. Friends, we know that the sun keeps nuclear fusion confined within its plasma. A question arises in the mind: how does snow accumulated in the clouds? Does the upper part of the Earth's atmosphere behave like the sun's plasma? Regions of Earth's atmosphere called the ionosphere contain some plasma that is created through ultraviolet radiation from the sun. The upper layers of Earth's atmosphere, the thermosphere and exosphere, and to a lesser extent the mesosphere, also contain plasma mixed in with atoms and molecules of different gases. The Earth's atmosphere has four primary layers: the troposphere, stratosphere, mesosphere and thermosphere. Those layers protect our planet by absorbing harmful radiation. Thermosphere 53 to 375 miles. In the thermosphere, molecules of oxygen and nitrogen are bombarded by radiation and energetic particles from the sun, causing the molecules to slide into their component atoms and creating heat. The thermosphere increases in temperature with altitude because the atomic oxygen and nitrogen cannot radiate the heat from this absorption mesosphere 31 to 53 miles. Studying the mesosphere is essential to understanding long-term changes in the Earth's atmosphere and how these changes affect climate. Since the mesosphere is responsive to small changes in atmospheric chemistry and composition, it could provide clues for scientists such as how added greenhouse gases may contribute to a change in temperature or water composition in the atmosphere. Stratosphere 10 to 31 miles. The ozone layer lies within the stratosphere and absorbs ultraviolet radiation from the sun. Troposphere 0 to 10 miles. The troposphere is a layer of the Earth's atmosphere where all human activity takes place. Ionosphere. The ionosphere is a layer of plasma formed by the ionization of atomic oxygen and nitrogen by highly energetic ultraviolet and X-ray solar radiation. The ionosphere extends from the middle of the mesosphere up to the magnetosphere. This layer cycles daily as the daytime exposure to solar radiation causes the ionization of the atoms that can extend down as far as the mesosphere. However, these upper atmospheric layers are still mostly neutral, with only 1 in a million particles becoming charged daily. At night, the ionosphere mostly collapses as the sun's radiation fuses to interact with the atoms in the thermosphere. There are still small amounts of charged atoms caused by cosmic radiation communication. A unique property of the ionosphere is that it can refract short wave, radio waves, enabling communication over great distances by bouncing signals of these ionized atmospheric layers. Variability of the ionosphere can interrupt satellite communication, such as errors in GPS signals for commercial air navigation. During solar storm, this layer can even shut down communication between ground station and satellite rockets, balloons and satellites. NASA scientists use balloons to collect in situ measurements in the atmosphere. However, the mesosphere and thermosphere are too high for balloons to reach, so Scientists use instruments on sounding rockets and satellites to gather more detailed measurements of the upper atmosphere. Noctilucent clouds in the mesosphere, evidence of change in the behavior of noctilucent cloud has been observed by the AIM mission. Recent data show dramatically lower ice content, leading scientists to speculate about changes in weather conditions and pole to pole atmospheric circulation. Aeronomy of ice in the mesosphere. AIM, NASA's AIM satellite, can remotely sense night shining clouds in the mesosphere. These noctilucent clouds are made of ice crystals that form over the summer poles at an altitude too high and a temperature too cold for water vapor clouds. BARREL. The balloon array for radiation belt relativistic electron losses barrel is a balloon-based mission to augment the measurement of NASA's RBSP spacecraft. BARREL seeks to measure the precipitation of relativistic electrons from the radiation belt during two multi-balloon campaigns operated in the southern hemisphere. Credit NASA Noctilucent Cloud, John Eric Paulsen, Barrel Image, NASA NSF. What is the upper part of the Earth's atmosphere? Exosphere. This is the outermost layer of the atmosphere. It extends from about 375 miles 600 kilometers to 6,200 miles 10,000 kilometers above the earth. In this layer, atoms and molecules escape into space and satellites orbit the earth. Water ripples, smoke rises, ice is stable, how to see falling is no. Ice is stable, how to see falling is no. Water ripples, smoke rises, ice is stable, how to see falling is no. Ice is stable, how to see falling is no. There is the water below, water above the sky. Difference between the two, water and the water. Difference between the two, water and the water. There is the water below, water above the sky. Difference between the two, water and the water. Difference between the two, water and the water. Water refills, the smoke is rises. Ice is stable. How to see falling is snow. Ice is stable. How to see falling is snow. Water repels, smoke is rises. Ice is stable. How to see falling is snow. Ice is stable. How to see falling is snow. Earth's atmosphere, what is plasma light? Ice in the water, smoke and snow in the sky too. Ice in the water, smoke and snow in the sky too. Earth's atmosphere, water is plasma light. Ice in the water, smoke and snow in the sky too. Ice in the water, smoke and snow in the sky too. Water repels, smoke rises. Ice is stable. How to see falling snow? Ice is stable. How to see falling snow? Water repels, smoke rises. Ice is stable. How to see falling snow? Ice is stable. How to see falling snow? Water from height always flows to the lower part. We know this. By the way, lakes, ponds and even wells are mostly stable, and still water may form ice, but I have never seen it. Well, while collecting water from the well of our house a few years ago, I also picked up a piece of ice. Can well water make ice? Yes, it is common for well water to be ice cold even in warmer climates. This is because well water comes from deep underground, where the temperature is generally cooler. The temperature of well water can also be influenced by factors such as the depth of the well and the geological characteristics of the area. 17 August 2021. Well water and fridge, ice maker, water dispenser help needed. Susan Pien 15 years ago. In our new build, I am going to have well water for the first time ever in choosing a fridge. I am trying to figure out if I want an ice maker and if I want through the door water ice dispenser. Considering only the well water issue, what are the pros cons in having both the ice maker and the door dispenser? Is it any difference than with municipal water in terms of filter I would need to get? Would the water ice look and taste fine, or would the well affect it? Thanks all. This is immensely helpful. Live where thanks except for the copper versus plastic pipe info. Really appreciate the advice and knowledge you are sharing. Hopefully our plumber will know that, but we are not quite there yet. Although the well is in 400 feet, if that matters. Definitely, thanks to. I guess we will wait and see what the water quality is like. Main Kunkiti, I am in Vermont, so we are practically neighbors. Nice to know you are so happy with your fridge and water. Can I get your service if I have well water? August 28, 2012. Reading time 3 minutes. Easy ice program. Well water and ice machine subscription. This is one of those maybe answer, turning the maybe to a yes. Depends on what water treatment you have installed or are planning to install. The real question is, what is the condition of the water after it leaves the filtration system? Here's a quick guide to understand the types of problems well water and water filtration systems cause with ice machines. If we can work with you to solve this, then we would be delighted to provide you with an easy ice machine subscription. Are you using the right ice melt near a well or water reservoir? Do you like winter? Yes, most of us do. They don't call it the most wonderful time of the year for nothing, but the slippery and icy sidewalk in winter can be challenging, as it can result in dangerous slip and fall accidents. Therefore, clearing snow and providing safe access to the driveway for your family and visitors becomes your responsibility. One of the most popular and effective ways to get rid of this treacherous layer of ice is by using ice melt. According to a study, 60% of American households use rock salt or salt-based ice melter products, but only 38% of them are aware of its hazard. We take generous amounts of rock salt and spread it in open areas like steps, driveways, sidewalks, etc. Some people even think that rock salt is safe to use and is natural snow melt, which is a big myth. How does water turn into ice? Ice structure. Point out that when water freezes, the water molecules have slowed down enough that their attractions arrange them into fixed positions. Water molecules freeze in a hexagonal pattern, and the molecules are further apart than they were in liquid water. Note, the molecules in ice would be vibrating. 21 August 2023. Frozen water, snow seen in soil, is in both hemispheres, ice and the ice. Is in both hemispheres, ice only ice. Frozen water, snow seen in soil, is in both hemispheres, is in the ice. Is in both hemispheres, ice only ice. Southern hemisphere, water. Northern hemisphere, soily rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Southern hemisphere, water. Northern hemisphere, soil or rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. And there are clouds in the air, atmosphere of snow even in the clouds. Falling clouds we can rain. Snowfall drop by drop of water. Snowfall drop by drop of water. And there are clouds in the air. Atmosphere of snow even in the clouds. Falling clouds we can rain. Snowfall drop by drop of water. Snowfall drop by drop of water. Frozen water, snow seen in soil, is in both hemispheres, ice only ice. Is in both hemispheres, ice only ice. Frozen water, snow seen in soil, is in both hemispheres, ice only ice. Is in both hemispheres, ice only ice. We sometimes refer to the source of water. Friends, when our doll Sneha was about 2 years old, we husband and wife had planned to go to my dad's house with Sneha. There we went with Sneha to have a picnic in the Semen River. The Semen River was coming from China. Semen River has come to Assam from Siang River of China. Friends, our entire team, including my wife, was camping near Semen rail bridge. But I and my little doll Sneha ran away towards the forest. After some time, my doll got tired due to the sun. So my doll started insisting on taking a bath. I was also feeling hot, so we both went down to the river to take a bath. The cold that I and my doll Sneha felt, I have not been able to forget even after 20 years have passed. If such a cold source of water forms in the river, then does ice not form? Why does ice form on the top of a lake? West Texas A&M University, https wtamu.edu, see Baird 2013 1205. Why does if such a cold source of water forms in the river, then does ice not form? From wtamu.edu, 5 December 2013. Right when the water freezes to ice, the ice becomes significantly less dense than the water and continues to float on the lake surface. In the winter, temperatures in a lake get close enough to freezing that the colder water is less dense and floats to the top. Public domain image source Christopher S. Baird. Below 4 degrees Celsius, water becomes less dense as it gets colder, causing water about to freeze to float to the top. Public domain image source Christopher S. Baird. Data source CRC Handbook of Chemistry and Physics. Ice in rivers. Formation and growth ice particles. The formation of ice in rivers is more complex than in lakes, largely because of the effects of water velocity and turbulence. As in lakes, the surface temperature drops in response to cooling by the air above. Unlike lakes, however, the turbulent mixing in rivers causes the entire water depth to cool uniformly even after its temperature has fallen below the temperature of maximum density 4 degrees centigrade or 39 degrees Fahrenheit. The general pattern is one in which the water temperature fairly closely follows the average daily air temperature, but with diurnal variations smaller than the daily excursion of air temperature. Once the water temperature drops to the freezing point and further cooling occurs, the water temperature will actually fall down below freezing, a phenomenon known as supercooling. Typically, the maximum supercooling that is observed is only a few hundreds of a degree Celsius. At this point, the introduction of ice particles from the air causes further nucleation of ice in the flow. This freezing action releases the latent heat of fusion, so that the temperature of the water returns towards the freezing point. Ice production is then in balance with the rate of cooling occurring at the surface. The particles of ice in the flow are termed fragile ice. Fragile is almost always the first ice formation in rivers. The particles are typically about 1 millimeter (0.04 inch) or smaller in size and usually in the shape of thin discs. Fragile appears in several types of initial ice formation. Thin sheet-like formations at very low current velocities, particles that appear to flocculate into larger masses and exhibit a dust-like appearance on the water surface. Irregularly shaped bands of fragile masses that, while appearing to be shallow, are actually of some depth and at high current velocities, a dispersed mixture or slurry of ice particles in the flow. The sustained supercooling of river water, while amounting to only a few hundredths of a degree Celsius or even less, provides the context for the particles to stick to one another. Since under such conditions, ice particles are inherently unstable and actively grow into the supercooled water. When they touch one another or some other surface that is cooled below the freezing point, they adhere by freezing. This behavior causes serious problems at water intakes where ice particles may adhere and then build up large accumulations that act to block the intake. In rivers and streams, fragile particles also may adhere to the bottom and successively build up a loose porous layer known as anchor ice. Conversely, if the water temperature then rises above the freezing point, the particles will become neutral and will not stick to one another, so that the flow will be merely when one of solid particles in the flowing water. The slightly above freezing water may also release the bond between anchor ice and the bottom. It is not unusual for another anchor ice to form on the bottom of shallow streams at night. When the cooling is great, only to be released the following day under the warming influence of air temperature and solar radiation. How does cold water turn into ice? Water and ice. Science Learning Hub. As the liquid cools down, the amount of potential energy is reduced and the molecules start to move slower. When the water temperature reaches around 0 degrees centigrade, the molecules stick together and form a solid ice. 19 July 2007. How does ice form on a river? Groundwater is warm and over time may melt the ice formed during very cold period. At other times, all the water in a small stream freezes. Subsequent improving water then flows over the surface and freezes, forming large buildups of ice. Water means icy news. Water, water, water. Icy news in no water. Water is smoky cloud. What a kind of nature is this snowing in the cloud? What a kind of nature is this snowing in the cloud? Water is smoky cloud. What a kind of nature is this snow in the cloud? What a kind of nature is this snowing in the cloud? Water, water, water. Icy news in no water. Water is smoke cloud. What a kind of nature is snowing in the cloud? What a kind of nature is snowing in the cloud? Water, smoky cloud. What a kind of nature is snowing in the cloud? What a kind of nature is snowing in the cloud? Rock in the water, stable inclusion of the ice. Wind in the sky, still is snowing in the snow. Still is snowing in the snow. Wind in the sky, still snowing in the snow. Still is snowing in the snow. Rock in the water, stable inclusion of the ice. Wind in the sky, still snowing in the snow. Still is snowing in the snow. Wind in the sky, still is snowing in the snow. Still is snowing in the snow. Water, water, water. Icy news in no water. Water is smoky cloud. What a kind of nature is this snowing in the cloud? What a kind of nature is this snowing in the cloud? Water, smoky cloud. What a kind of nature is this snowing in the cloud? What a kind of nature is this snowing in the cloud? Water, water, water. I see news in no water. Water is smoky cloud. What a kind of nature is this snowing in the cloud? What a kind of nature is this snowing in the cloud? Water, smoky cloud. What a kind of nature is this snowing in the cloud? What a kind of nature is this snowing in the cloud? Friends, a puzzle is not being solved somehow. It is said that due to plasma, the sun is circular ball because inside the plasma there is about 15,000 million degrees Fahrenheit or more temperature which is inside the plasma. However, the temperature in the outer plasma remains at least 3 million degrees. But even though the earth is surrounded by plasma, how do ice rocks form in the clouds? Ice crystals form in a cloud through a process called nucleation. This process occurs when water vapor in the atmosphere condenses onto small particles such as dust, pollen or other airborne particles. 27 April 2016. Earth's magnetosphere protecting our planet from harmful space energy by Alan Boyce, NASA's Jet Propulsion Laboratory. Of the four rocky planets in our solar system, you could say Earth's magnetic personality is the envy of its temporary interplanetary neighbor. Unlike Mercury, Venus, and Mars, Earth is surrounded by a vast magnetic field called the magnetosphere, generated by the powerful dynamic forces at the center of our world. Our magnetosphere protects us from erosion by the solar wind. Charged particles our sun constantly spews at Earth. Coronal mass ejection, energetic giant clouds, and the erosion of our atmosphere by particle radiation shape and magnetize solar plasma and radiation and cosmic rays from deep space. Our magnetosphere plays the role of gatekeeper, repelling this unwanted energy that is harmful to life on Earth and trapping most of it at a safe distance from the Earth's surface in two donut-shaped regions called the Van Allen belts. It is said space weather effects of space weather credit NOAA. But Earth's magnetosphere is not a perfect protection. Variations in the solar wind can disturb it, causing space weather. Geomagnetic storms that can penetrate our atmosphere, threatening spacecraft and astronauts, disruption, navigation system, and can wreak havoc on the power grid. On the positive side, these storms also produce Earth's spectacular aurora. The solar wind creates temporary cracks in the shield, allowing some energy to reach the Earth's surface every day. However, since this intrusion are brief, they do not cause significant problems. Get NASA's climate change news. Subscribe to the newsletter. Because the forces that generate Earth's magnetic field are constantly changing, this field is also in constant flux, with its strength increasing and decreasing over time. This causes the Earth's magnetic north and south pole to change position slowly and completely change position approximately every 3 lakhs years. You can learn why changes and shifts in the polarity of the magnetic field have no effect on climate on the time scale of human lifetime and are not responsible for the Earth's recently observed warming. How is ice formed in cloud? Cloud development. If the air parcel is raised high enough in the troposphere, the dew point temperature will be very low and small ice crystals will begin to form. Supercloud water droplets will also freeze when they come in contact with this ice nuclei. What causes ice crystals in the sky? Since warm air often contains more water vapor than cold air, this mixing will usually also carry water vapor into the air near the surface, increasing the relative humidity of the near surface air. If the increase in relative humidity near the surface is high enough, ice crystals may form. Is ice considered a rock? Natural ice is both a mineral and a rock. It meets all the requirements to be a mineral and is so massive that its qualifies as a mono-mineral rock like limestone, dolomite and arguably gypsum and salt. Like all of these, ice is also a sedimentary rock. Man-made ice is neither a rock not a mineral. 29 March 2019. Water. I see news in no water. Water is smoky cloud. What a kind of nature is this snowing in the cloud? What a kind of nature is this snowing in the cloud? Water is smoky cloud. What a kind of nature is this snowing in the cloud? What a kind of nature is this snowing in the cloud? Water. I see news in no water. Water is more cloud. What a kind of nature is snowing in the cloud? What a kind of nature is snowing in the cloud? Water, smoky cloud. What a kind of nature is snowing in the cloud? What a kind of nature is snowing in the cloud? Rock in the water, stable inclusion of the ice. Wind in the sky, still is snowing in the snow. Still is snowing in the snow. Wind in the sky, still snowing in the snow. Still is snowing in the snow. Rock in the water, stable inclusion of the ice. Wind in the sky, still snowing in the snow. Still is snowing in the snow. Wind in the sky, still is snowing in the snow. Still is snowing in the snow. Water. I see news in no water. Water is smoky cloud. What a kind of nature is snowing in the cloud? What a kind of nature is snow in the cloud? What a smoky cloud. What a kind of nature is snow in the cloud? What a kind of nature is snow in the cloud? Water, I see news in water. Water is smoky cloud. What a kind of nature is snow in the cloud? What a kind of nature is snow in the cloud? Water, smoky cloud. What a kind of nature is snow in the cloud? What a kind of nature is snow in the cloud? Water means icy structure. Can ice form without water in the earth's surface due to cold? How does ice form without water? Ice can form without the presence of liquid water through a process called sublimation. Sublimation occurs when a substance transitions directly from a solid to a gas without passing through the liquid phase. However, in the context of your freezer, the ice is generated from the water vapor present in the air. 13 March 2021. Why does ice form on the top of a lake? West Texas A&M University. https wtamu.edu C. Belt 2013 1205. Why does can ice form without water in the earth's surface due to cold? From wtamu.edu 5 December 2013, as the layer cools to its freezing point, ice begins to form on the surface of the lake. In deep lakes, water pressure may also play a role. Does ice need water to form? It forms when water freezes at temperature below 0 degrees Celsius, 32 degrees Fahrenheit. So ice cannot exist without water. 9 August 2019. Ice is water in its frozen solid form. Ice often forms on lakes, rivers and the ocean in cold weather. It can be very thick or very thin. It occurs as frost, snow, sleet and hail. Water will freeze at 0 degrees Celsius, 32 degrees Fahrenheit. Once it gets close to its freezing point, water molecules begin to expand in a small space. These expanding molecules can create a lot of pressure. This is why freezing water can burst even the heaviest of metal pipes in the winter. This is also the reason your ice tray at home can look like it's overflowing with ice, even though you only filled it halfway with water. If water freezes in a crack in rock, the ice can eventually break the rock part. Because of this powerful properties, ice is very important in the processes of weathering, where rocks are broken into smaller bits, and erosion, where rocks and earth are washed or moved to other locations. The expanded molecules make ice a lot lighter than liquid water, which is why ice floats. An iceberg that weighs several tons can still float easily in the ocean, just like a piece of ice floats easily in your cup of water or soda. Water covers more than 70% of Earth's surface. Slightly more than 2% of Earth's water is frozen into ice. Almost all of this ice is in glaciers, which are huge masses of ice. Today, glaciers are found in many mountainous areas and in the polar regions of Earth. Ice. Wikipedia, HTTPS, in Wikipedia organization, Wiki Ice. Can ice form without water in the Earth's surface due to cold? Form from EN Wikipedia organization. Ice is water that is frozen into a solid state, typically forming at or below temperatures of 0 degree centigrade, 32 degree Fahrenheit or 273.15 K as a naturally occurring crystalline inorganic solid with an ordered structure. Ice is considered to be a mineral. Depending on the presence of impurities such as particles of soil or pebbles of air, it can appear transparent or a more or less opaque bluish white color. Water and ice. Science Learning Hub. HTTPS www.science-learn-organization NZ resources 1008. Can ice form without water in the Earth's surface due to cold? From www.science-learn-organization NZ 19 July 2007, when the water temperature reaches around 0 degree centigrade, the molecules stick together and form a solid ice. Frozen water, snow seen in soil, is in both hemispheres, ice and the ice. Is in both hemispheres, ice only ice. Frozen water, snow seen in soil, is in both hemispheres, is in the ice. Is in both hemispheres, ice only ice. Southern hemisphere, water. Northern hemisphere, soily rocky. Both hemispheres cool every moment. Becomes a story of the snow. Becomes a story of the snow. Southern hemisphere, water. Northern hemisphere, soil or rocky. Both hemispheres cool every moment. Becomes a story of the snow. becomes the story of snow. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. And there are clouds in the air, atmosphere of snow even in the clouds. Falling clouds became rain. Snowfall drop by drop water. Snowfall drop by drop water. And there are clouds in the air. Atmosphere of snow even in the clouds. Falling clouds become rain. Snowfall drop by drop water. Snowfall drop by drop water. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. Three alternatives of water. One is smoke, the other is ice, but this one is snowflake. Just calling this snowflake snow does not do it justice. Why snow is not solid ice? This molecular structure of snow is similar to that of ice, but it is much less dense and contains more air pockets. This is why snow is often considered a porous material. The density of snow varies greatly depending on the circumstances under which it was developed. Wikipedia, HTTPS, EN Wikipedia Organization, Wiki, Snow. Snow comprises individual ice crystals that grow while suspended in the atmosphere, usually within clouds, and then fall, accumulating on the ground where they undergo further changes. It consists of frozen crystalline water throughout its life cycle, starting when under suitable conditions the ice crystals form in the atmosphere, increase to millimeter size, precipitate and accumulate on surfaces, then metamorphose in place and ultimately melt, slide or sublimate away. Snow storms organize and develop by feeding on source of atmospheric moisture and cold air. Snowflakes nucleate around particles in the atmosphere by attracting supercooled water droplets which freeze in hexagonal shape crystals. Snowflakes take on a variety of shapes. Basic among these are platelets, needless, columns and rim. Accumulated snow morphosis by sintering, sublimation and freeze thaw, where the climate is cold enough for year to year accumulation, a glacier may form. Otherwise, snow typically melts seasonally, causing runoff into streams and rivers and recharging groundwater. Major snow-prone areas include the polar regions, the northernmost half of the northern hemisphere, and mountainous regions worldwide with sufficient moisture and cold temperatures. In the southern hemisphere, snow is confined primarily to mountainous areas apart from Antarctica. Snow affects such human activities as transportation, creating the need for keeping roadways, wings and windows clear, agriculture, providing water to crops and safeguarding livestock, sports such as skiing, snowboarding and snow machine travel, and warfare. Snow affects ecosystems as well by providing an insulating layer during winter under which plants and animals are able to survive the cold. Why is snow not solid? Snow is a solid until the temperature rises enough to cause a phase change to a liquid. However, under low humidity, the liquid formed as the snow crystals melt may undergo a further phase change as it evaporates into the atmosphere. 1 February 2016. Why is snow not ice? Ice and snow. NESDIS. Snow is precipitation in the form of ice crystal. It originates in clouds when temperatures are below the freezing point 0 degrees Celsius or 32 degrees Fahrenheit. When water vapor in the atmosphere condenses directly into ice without going through the liquid stage. This earth is amazing. This snow is not ice, but it is still snow. The real surprising truth is the earth's composition of water, soil and air. This is the formation of the earth, water, soil and air. Ice in water, clouds in the air, snow dominates even in the clouds. Ice in water, clouds in the air, snow dominates even in the clouds. This is the formation of the earth, water, soil and air. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice stable in the water, above frozen water. Clouds flow, how the snow floats on the clouds. Clouds float, how the snow floats on the cloud. I stay in water, above frozen water. Clouds float, how the snow floats up with the clouds. Clouds float, how the snow floats on the clouds. This is the formation of the earth, water, soil and air. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. This is the formation of the earth, water, soil and air. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. Oh, waving means melting of ice in the water, floating a cloud. How to stop the burning of the ice? Floating a cloud. How to stop the burning of the ice? Oh, waving means melting of the ice in the water, floating a cloud. How to stop the burning of the ice? Floating a cloud. How to stop the burning of the ice? This is the formation of the earth, water, soil and air. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. This is the formation of the earth, water, soil and air. Ice in the water, clouds on the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. It is said that mobility means being energetic. Dynamic water can never form ice, although current can certainly produce ice. Water must be stable to form ice. It is the nature of clouds to float in the sky. Then how can ice freeze in floating clouds? Certain types and sizes of dust and salt particles such as sea salt and clay form the best condensation nuclei. With a reasonable amount of water, vapor and dust in the air parcel, the next step is to cool the air parcel mass to a temperature at which cloud droplets or ice crystals can form. How are clouds formed? NASA Climate Kit Government, HTTP Climate Kit NASA Government Cloud Formation. Clouds form when water vapor and invisible gas turns into liquid water droplets. These water droplets form on small particles like dust which are floating in the air. You hang up the wet towel and when you come back it is dry. You hold out a bowl of water for your dog and when you look again the water level in the bowl has dropped. Although Ufi is now here near the bowl. Where did the missing water go? It evaporated. This means that some of the liquid water in the towel or bowl turned into an invisible gas called water vapor and escaped into the atmosphere. Note that evaporated includes the word vapor. The same thing is constantly happening with oceans, lakes, rivers, swamps, swimming pools, and everywhere water is in contact with air. Liquid water turns into gas when water molecules receive additional energy from a heat source such as the sun or from other water molecules flowing into them. These energetic molecules then escape out of the liquid water as gas. In the process of changing from liquid to gas, the molecules absorb heat, which they carry with them into the atmosphere. Due to this, the water released by them gets cooled. Work is currently underway at the Manchester Ice Cloud Chamber to investigate the formation of ice crystals in cloud. There are several ways in which ice crystals can form in cloud at temperatures below 0 degrees centigrade. One method involves the relatively rare presence of a particle known as an ice nucleus within a water drop that acts as a catalyst for freezing. A liquid water drop that freezes into solid ice in this way is said to be nucleated, and when this happens at temperatures between 0 to 36 degrees centigrade, it is specifically called anomalous nucleation. Examples of such nucleating centers include dust, minerals, black carbon, and some organic materials such as leaf litter, lysine, and bacteria such as Pseudomonas strain. Biological sources are capable of forming ice crystals at the highest temperatures possible. Which clouds produce snow? Cirrus clouds. Cirrus clouds are thin, feathery, and composed entirely of ice crystals. They are often the first sign of an approaching warm front or upper level jet stream. How does ice float in clouds? The water droplets and ice crystals that form clouds are not floating because they have been absorbed by a sponge-like material that is holding them in place. Rather, the water droplets and ice crystals that form clouds float because they are so small that air resistance balances gravity. 7th February 2014. Can ice form in clouds? How is the made ice made of it? Snow is formed when small ice crystals in clouds stick together and form snowflakes. If enough crystals stick together, they will become heavy enough to fall to the ground. Snowflakes that descend through most air, moist air that is slightly warmer than 0 degree centigrade will melt around the edges and stick together to form larger pieces. This is the formation of the earth, water, soil and air. Ice in water, clouds in the air, snow dominates even in the clouds. Ice in water, clouds in the air, snow dominates even in the clouds. This is the formation of the earth, water, soil and air. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice stable in the water, above frozen water. Clouds flow, how the snow floats on it, the clouds. Clouds flow, how the snow floats on it, the clouds. High stable water, above frozen water. Clouds flow, how the snow floats up with the clouds. Clouds flow, how the snow floats on it, the clouds. This is the formation of the earth, water, soil and air. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. This is the formation of the earth, water, soil and air. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. Oh, waving means melting of ice in the water, floating a cloud. How to stop the burning of the ice? Floating a cloud. How to stop the burning of the ice? Oh, waving means melting of the ice in the water, floating a cloud. How to stop the burning of the ice? Floating a cloud. How to stop the burning of the ice? This is the formation of the earth, water, soil and air. Ice in the water, clouds in the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. This is the formation of the earth, water, soil and air. Ice in the water, clouds on the air, snow dominates even in the clouds. Ice in the water, clouds in the air, snow dominates even in the clouds. Earth is a constituent of water, soil and atmosphere. How much water, soil and atmosphere does the earth have? How much land and water is there on earth? About 71% of the earth's surface is water and the remaining 29% is land. Most of the water on earth's surface is salt water in the oceans. What percentage of gaseous atmosphere is there in the earth? Earth's atmosphere is composed of approximately 78% nitrogen, 21% oxygen, 0.9% argon and 0.1% other gases. 19 October 2023. Then what will be the water, soil and gaseous state of the earth entire? On earth you can find water in all three stages of matter: solid, liquid and gas. Liquid water is found in earth, oceans, rivers, lakes, springs and even in the soil and underground. Solid ice is found in glaciers, ice caps and at the north and south poles. Water vapor, a gas, is found in Earth's atmosphere. 22 October 2020. Is there water in the ground and what percentage is the gaseous atmosphere in the earth? Effects of changing the carbon cycle. NASA Earth Observatory Government, HTTPS Earth Observatory NASA Government. Features, page 5. Atmosphere. It is important that so much carbon dioxide remains in the atmosphere because CO2 is the most important gas for controlling Earth's temperature. Carbon dioxide, methane and halocarbons are greenhouse gases that absorb a wide range of energy, including infrared energy, heat emitted by the earth and then re-emit it. The re-emitted energy spreads in all directions, but some returns to earth, where it warms the surface. Without greenhouse gases, earth would be frozen at -18 degrees centigrade, 0 degree Fahrenheit. With so many greenhouse gases, earth would be like the planet Venus, where a greenhouse atmosphere keeps temperature around 400 degrees Celsius, 750 degrees Fahrenheit. Ocean. About 30% of the carbon dioxide put into the atmosphere by people has spread into the ocean through direct chemical exchange. Carbon dioxide is formed when carbon dioxide dissolves in the sea, which increases the acidity of water, or rather a slightly alkaline. Ocean becomes slightly less alkaline. Since 1750, sea surface pH has fallen by 0.1, a 30% change in acidity. Land. Plants on land have absorbed approximately 25% of the carbon dioxide released into the atmosphere by humans. The amount of carbon taken up by plants varies greatly from year to year. But in general, the world's plants have increased the amount of carbon dioxide absorbed since the 1960s. Only some of this increase has occurred as a direct result of fossil fuel emissions. Frozen water, snow seen in soil, is in both hemispheres, ice and the ice. Is in both hemispheres, ice only ice. Frozen water, snow seen in soil, is in both hemispheres, is in the ice. Is in both hemispheres, ice only ice. Southern hemisphere, water. Northern hemisphere, soily rocky. Both hemispheres full every moment. Becomes the story of the snow. Becomes the story of the snow. Southern hemisphere, water. Northern hemisphere, soil or rocky. Both hemispheres cold every moment. Becomes the story of the snow. Becomes the story of the snow. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. And there are clouds in the air, atmosphere of snow even in the clouds. Falling clouds became rain. Snowfall drop by drop of water. Snowfall drop by drop of water. And there are clouds in the air. Atmosphere of snow even in the clouds. Falling clouds become rain. Snowfall drop by drop of water. Snowfall drop by drop of water. Frozen water, snow seen in soil, is in both hemispheres, ice only ice. Is in both hemispheres, ice only ice. Frozen water, snow seen in soil, is in both hemispheres, ice only ice. Is in both hemispheres, ice only ice. Earth is basically water, soil, air, where the earth is formed mainly under light. And this is why the earth is organic or biological. How does the earth carbon cycle work? Plants continuously exchange carbon with the atmosphere. Plants absorb carbon dioxide during photosynthesis, and most of the carbon dioxide is stored in roots, permafrost, grassland and forest. Plants and soil release carbon dioxide when they decompose. Carbon cycle. Carbon is the backbone of life on earth. We are made of carbon, we eat carbon, and our civilization, our economics, our homes, our modes of transportation are built on carbon. We need carbon, but that need is also linked to one of the most pressing problems facing us today: global climate change. Carbon formed in the centers of aging stars is the fourth most abundant element in the universe. Most of Earth's carbon, about 65,500 billion metric tons, is stored in rock, which rest is in the ocean, atmosphere, plants, soil and fossil fuel. Carbon flows between each reservoir in an exchange called the carbon cycle, which has slow and fast components. Any change in the cycle that moves carbon out of one reservoir puts more carbon into other reservoirs. Changes involving carbon gases in the atmosphere result in warmer temperatures on Earth. Over long periods of time, the carbon cycle maintains an equilibrium that prevents all of Earth's carbon from entering the atmosphere as on Venus or from being stored in rocks entirely. This balance helps keep Earth's temperature relatively constant, like a thermostat. As per of the slow carbon cycle, this thermostat operates for a few million years. This means that over short time period, from tens to a million years, the Earth's temperature can vary, and in fact, each oscillates between ice ages and warm interglacial periods on this time scale. Part of the carbon cycle can also amplify these short-term temperature changes. Graph of deep ocean oxygen isotope ratio and the past 67 million years. The uplift of the Himalayas, which began 50 million years ago, reset Earth's thermostat by providing a huge source of fresh rock to pull more carbon into the slow carbon cycle through chemical. The ratio between heavy and light oxygen in the deep ocean changes as a result of falling temperatures and the formation of ice sheets. As shown as in the graph based on data from Jacobs 8L2001. On a very long time scales, millions to tens of millions of years, changes in the movement of the tectonic plates and the rate at which carbon seeps out of the Earth's interior can alter the temperature at the thermostat. The Earth has changed over the past 50 million years from the extremely warm climate of the Cretaceous about 145 to 65 million years ago to the glacial climate of the Pleistocene about 1.8 million to 11,500 years ago. For more information on geologic eras, see division of geologic time, measure chronological and geochronological units. This world with habitable zone of carbon cycle is basically a world of water. Water which is present in the form of smoke, ice and snow, which is H2O. By the way, a clear description of the carbon cycle is found in smoke. It's just one part water, smoke, ice and snow. Chemistry name of which one says H2O. Chemistry name of which one says H2O. It's just one part water, smoke, ice and snow. Chemistry name of which one says H2O. Chemistry name of which one says H2O. Hydrogen, oxygen together form water. How to make ice? That is an accident. How to make oil? That is an accident. Hydrogen, oxygen together form water. How to make ice? That is an accident. How to make ice? That is an accident. It's just one part water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. It's just one part water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. Water is liquid, smoke is water vapor. Ice is sign, mirror is in nature. Ice is sign, mirror in nature. Water is liquid, smoke is water vapor. Ice is sign, mirror nature. Ice is sign, mirror nature. It's just one part water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. It's just one part water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. Water and mirror follow somewhat similar action. Smoke is either invisible or darkness persists even in light. Why does this snow leave everyone behind in the glow? Sparkle of Christmas lights under the snow. Reddit are mild interesting. 220 plus comment 6 years ago. You may see it for a while after a fresh fall frost, but incandescent bulbs will certainly melt the snow in no time. The short answer is that it is a production inspection. There's really no story answer to this, mostly because we don't know enough. Why does snow glow in the dark? This glow occurs because when electrons penetrate the ice, they energize the material. The frozen water then relaxes some of the energy as light, with different atoms and molecules emitting light at different wavelengths. A similar process occurs in the northern lights, says Gudipati, 11 November 2020. Why does snow glow blue? Why is glacier ice blue? US Geological Survey. Glacier ice is blue because the red longer wavelength portion of white light is absorbed by the ice, and the blue shorter wavelength portion of light is transmitted and scattered. The longer light travels through snow, the more blue it appears. Can snow reflect rainbow? What you see is a beautiful demonstration of the circumferential horizontal arc, and like other rainbow type displays in the sky, this arc results from the refraction of light from a few drops of water. Although in this case they are teeny pieces of the ice. 19 August 2021. Can ice become a mirror? If the packed ice melts for a while, water enters the remaining air spaces and freezes again, causing the packed mass to harden and the surface to become smoother. Smooth, transparent, hard ice is now called black ice. Like a mirror, its smooth surface reflects light in one direction. It's just one part, water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. It's just one part, water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. Hydrogen, oxygen together form water. How to make ice? That is an accident. How to make ice? That is an accident. Hydrogen, oxygen together form water. How to make ice? That is an accident. How to make ice? That is an accident. It's just one part. Water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. It's just one part. Water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. Water is liquid, smoke is water vapor. Ice is science, mirror is nature. Ice is science, mirror in nature. Water is liquid, smoke is water vapor. Ice is science, mirror nature. Ice is science, mirror nature. It's just one part. Water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. It's just one part. Water, smoke, ice and snow. Chemistry name of each one says H2O. Chemistry name of each one says H2O. Water, smoke, ice and snow, these four gifts of nature are actually just different divisions of water. By the way, everyone's chemistry name is H2O. The difference is that the change in smoke occurs only due to the coordination of dust particles. Why is the natural chemical name of smoke different? Smoke. Wikipedia, HTTPS, in Wikipedia organization, Wiki smoke. Smoke is a suspension of airborne particles and gases emitted when a material undergoes combustion of pyrolysis together with the quantity of air gas. Chemical composition, dangerous measurement, medical smoking. What is smoke and why do some fires seem to have more smoke than others? Smoke is a collection of teeny solid, liquid and gas particles. Although smoke can contain hundreds of different chemicals and fumes, visible smoke is mostly carbon, soot, tar, oil and ash. Smoke occurs when there is incomplete combustion, not enough oxygen to burn the fuel completely. In complete combustion, everything is burned, producing just water and carbon dioxide. When incomplete combustion occurs, not everything is burned. Smoke is a collection of these teeny unburned particles. Each particle is too small to see with your eyes, but when they come together, you see them as smoke. Smoke is a visible collection of a variety of solid, liquid and gas particles left unburned during the combustion process, figure 1. It is possible for smoke to contain a large number of different chemicals and fumes, although visible smoke is mostly carbon or soot. tar, oils and ash. Because of its long list of components, smoke can contain a variety of different pollutants. Smoke is created when a substance undergoes incomplete combustion. This simply means that there is not enough oxygen present when the material is burned to completely burn the fuel. Instead of only carbon dioxide and water vapor being created, incomplete combustion can result in the production of salt, smoke and ash. There are a variety of different sources of smoke including Wikipedia, HTTPS EN Wikipedia organization, Wiki, liquid smoke. Liquid smoke is a water soluble yellow to red liquid used as a flavoring as a substitute for cooking with wood smoke while retaining a similar flavor. It can be used to flavor any meat or vegetable. It is available as pure condensed smoke from various types of wood and as derivative formulas containing additives. What are the different chemicals in smoke? The gas phase of cigarette smoke includes nitrogen N2, oxygen O2, carbon dioxide CO2, CO, acetaldehyde, methane, hydrogen, cyanide, HCN, nitric acid, acetone, acetylene, ammonia, methanol, hydrogen sulfide, H2S, hydrocarbons, gas phase, nitrosamine and carbonyl compound, Borgering and Close 2005. What is the chemical composition of the smoke? Smoke is a composed primarily of carbon dioxide, water vapor, carbon monoxide, particulate matter, hydrocarbon and other organic chemicals. Nitrogen oxide, trace minerals and several thousand other compounds. The actual composition of smoke depends on the fuel type, the temperature of the fire and the wind condition. 12 December 2018. Is hydrogen cyanide is smoke? A wide range of combustion processes produce hydrogen cyanide gas in the smoke or fume, including building fire, cigarettes, vehicle exhaust and fires involving nitrogen containing materials such as polyurethane foams. 21 April 2020. Frozen water, snow seen in soil, is in both hemispheres, eyes and the eye. Is in both hemispheres, eyes only eyes. Frozen water, snow seen in soil, is in both hemispheres, is in only ice. Is in both hemisphere, ice only ice. Southern hemisphere, oh water. Northern hemisphere, soily rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Southern hemisphere, oh water. Northern hemisphere, soil or rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. Frozen water, snow seen in soil, is in both hemispheres, ice on the ice. Is in both hemispheres, ice on the ice. And there are clouds in the air, atmosphere of snow even in the clouds. Falling clouds weaken rain. Snowfall drop by drop water. Snowfall drop by drop water. And there are clouds in the air. Atmosphere of snow even in the clouds. Falling clouds weaken rain. Snowfall drop by drop water. Snowfall drop by drop water. Frozen water, snow seen in soil, is in both hemisphere, ice only ice. Is in both hemisphere, ice only ice. Frozen water, snow seen in soil, is in both hemisphere, ice only ice. Is in both hemisphere, ice only ice. Water is a strange subject. Water is liquid, but it also turns into vapor or smoke, which is called gaseous substance. And water is also a solid, what we call ice. Just as ice is the pride of the sea, ice also keeps forming in the sky, but when solid ice falls from the sky to the surface, it falls in two ways. One is snow, the other is ice chunks, rain or stone rain. How do snow and ice pieces fall from the sky in two ways? Precipitation that falls onto the ground in the form of ice crystals is called snow. The rain that falls onto the surface of the earth as water droplets from clouds but freezes before it reaches the ground, forming teeny ice crystal, is called sleet or ice pellets, also called rain ice. 28 May 2020. What is the difference between ice and snow? Thought Co. https www.thoughtco.com. Science Chemistry 7th December 2019. Ice and snow are both solid forms of water or H2O, but they each have distinct characteristics. How does the snow fall from the sky? How does snow form made of it? Snow forms when teeny ice crystals in clouds stick together to become snowflakes. If enough crystals stick together, they will become heavy enough to fall to the ground. Snowflakes that descend through moist air that is slightly warmer than 0 degrees centigrade will melt around the edges and stick together to produce big flakes. How does ice fall from sky? Larger balls of ice can fall from the sky. Fleet Science Center. Hail starts as the rain droplets that freeze at high altitude with the right conditions. These frozen rain droplets combine with other droplets and grow larger until the hail gets heavy enough to drop from the storm cloud. How fast does snow fall from the sky? 10 facts about snow made of it. Between 1 to 4 mph. Most snow falls at a speed of between 1 to 4 mph dependent upon the individual snowflake mass and surface area, as well as the environmental conditions surrounding its descent. What falls from sky in winter? But when the temperature in the sky decreases by several degrees below zero, then the air gets accumulated in the form of small drops of water. Water is accumulated on these frozen droplets and gradually they form the shape of ice crystals, which are known as hail. 1 June 2018. What are balls of ice falling from the sky called dews? As the mix of snow and supercooled water continues to pass through a layer of below freezing air, the water will refreeze over the snow into teeny balls of ice, which we call graupels. 18 November 2020. Can rain turn to snow? This is not just sloppy, it is seriously misleading because rain never actually turns to snow. It is a physical impossibility. However, snow does turn to rain all the time. How do ice crystals fall? Once an ice crystal has formed, it absorbs and freezes additional water vapor from the surrounding air, growing into a snow crystal or snow pellet, which then falls to earth. Snow falls in several forms. Snowflakes are clusters of ice crystals that hail from a cloud. Only after the water vapor and dust particles come together in the form of a cloud, snow forms and various types of rain occur. Vapor, dust particles, every moment is in the air. How clouds were formed? How are the ice crystals in the cloud? How clouds were formed? How are the ice crystals in the cloud? Vapor, dust particles, every moment is in the air. How clouds were formed? How are the ice crystals in the cloud? How clouds so are formed? How are the ice crystals beneath the clouds? Clouds always so fall like a watery drop. Crystal icy rock, how can it fall like a snow? Crystal icy rock, how can it fall like a snow? Clouds also fall like a watery drop. Crystal icy rock, how can it fall like a snow? Crystal icy rock, how can it fall like a snow? Vapor dust particles, every moment is in the air. How clouds so are formed? How are the ice crystals in the clouds? How clouds so are formed? How are the ice crystals in the clouds? Vapor dust particles, every moment is in the air. How clouds so are formed? How are the ice crystals in the clouds? How clouds so are formed? How are the ice crystals in the clouds? Water from the bottom, smoke rises to the sky. It is said that clouds fall to the ground as we fall. It is said that the clouds fall to the ground as we fall. Oh, water from the bottom, smoke rises to the sky. It is said that the clouds fall to the ground as they fall. It is said that the clouds fall to the ground as they fall. Vapor dust particles, every moment is in the air. How clouds so are formed? How are the ice crystals in the clouds? How clouds so are formed? How are the ice crystals in the clouds? Vapor dust particles, every moment is in the clouds. How clouds so are formed? Happy are the crystals in the clouds. How clouds so are formed? How are the ice crystals in the clouds? Friends, this morning I was in a lot of trouble. I was surprised. What is the matter? What are you probably thinking? Is not it, friends? Actually, the thing is that I go to work at night and return home from work in the morning. Today I was returning home early in the morning. What can I say, friends? My train probably crossed two signal posts from Howrah. After this, my train ran so slowly all the way to the destination that I was late my a full 37 minutes. When I reached Belur platform, I got angry and scolded the driver. Then the driver slowly explained to me that due to the fog, there was difficulty in understanding the signal post. What is this fog? Is fog a cloud? Fog is a cloud that touches the ground. Fog can be thin or thick, meaning people have difficulty seeing through it. In some situations, fog can become so dense that it becomes difficult to drive safely as it obscures the road and other cars. 19 October 2023. Fog. Wikipedia HTTPS in Wikipedia organization. Wiki fog. Fog is a visible aerosol consisting of small water droplets or ice crystals suspended in the air at a or near the Earth's surface. Fog can be considered a type of low cloud that typically resembles stratus and is significantly influenced by nearby water bodies, topography, and wind conditions. In turn, fog affects many human activities such as shipping, travel, and warfare. Fog appears when water vapor, water in gaseous form, condenses. During condensation, water vapor molecules combine to form teeny liquid water droplets that large hand in the air. Sea fog, which appears near bodies of salt water, forms as water vapor, condenses on salt flats. Fog is similar to mist but less transparent. Action News 5. HTTPS www.actionnews5.com 2021 4/28. Breakdown: why are fog and clouds different? Memphis, Tennessee's WMC. Fog and clouds may look alike, but they are considered two different things depending on where they actually form. Similar to clouds, fog forms when water condenses in the air. This is achieved by either increasing humidity or cooling the air to convert water vapor into liquid. With more moisture on the ground, such as after rain, fog will be more likely to form. Additionally, sometimes liquid water will turn into ice when cooled enough. This is called snow fog and is common in Alaska. However, fog forms only on the surface. If it forms above the surface, it will be considered a cloud, not fog. In fact, fog is most common on clear nights when there are no clouds in the sky. Clouds form at many different altitudes and can be several times miles above the surface, so the only real difference between clouds and fog is the height. Typically, if it is less than 50 feet, it is considered fog. If it is more than 50 feet high, it is considered a cloud. Copyright 2021 WMC, all rights reserved. Is fog the same as clouds? There is no difference between fog and clouds except height. Fog is defined as visible moisture that begins at an altitude of less than 50 feet. If visible moisture starts at or above 50 feet, it is called a cloud. The two common types of fog are called radiation fog and convection fog. How is fog formed? Fog material. Fog forms when the air at or near the earth's surface becomes saturated by one of three processes: cooling, adding moisture, or mixing with another air parcel. Typically, fog forms in environments with stable air masses. Can we make fog? Drop a few pieces of dry ice directly into hot water. You will immediately see a lot of fog. As a general rule, 1 pound of dry ice will create a fog effect for 2 to 3 minutes. Paper dust particle every moment is in the air. How clouds overform, how are the ice crystal in the cloud? How clouds overform, how are the ice crystals in the cloud? Paper dust particle every moment is in the air. How clouds form, how are the ice crystals in the cloud? How clouds are formed, how are the ice crystals in the cloud? Clouds also fall like a watery drop. Crystal icy rock, how can it fall like snow? Crystal icy rock, how can it fall like snow? Clouds also fall like a watery drop. Crystal icy rock, how can it fall like snow? Crystal icy rock, how can it fall like snow? Paper dust particles every moment is in the air. How clouds are formed, how are the ice crystals in the cloud? How clouds are formed, how are the ice crystals in the cloud? Vapor dust particles every moment is in the air. How clouds are formed, how are the ice crystals in the cloud? How clouds are formed, how are the ice crystals in the cloud? Water from the bottom, smoke rises to the sky. It is said that clouds fall to the ground as we fall. It is said that the clouds fall to the ground as we fall. Oh, water from the bottom, smoke rises to the sky. It is said that the clouds fall to the ground as we fall. It is said that the clouds fall to the ground as we fall. Vapor dust particles every moment is in the air. How clouds are formed, how are the ice crystals in the cloud? How clouds are formed, how are the ice crystals in the cloud? Vapor dust particles every moment is in the cloud. How clouds are formed, are the crystals in the cloud? How clouds are formed, how are the ice crystals in the cloud? Vapor, dust, particles, etc. gather together and take the shape of clouds in the sky. We know that vapor is gas. But which substance is the cloud? Gas or liquid or solid? The water that makes up cloud is in liquid or ice form. The air around us is partially made up of invisible water vapor. It's only when that water vapor cools and condenses into liquid water droplets or solid ice crystal that visible clouds form to March 2017. Cloud Development, National Weather Service, Government. https www.weather.com JDITU Cloud. Wind is the horizontal movement of air transporting energy transformed from the Earth's surface as sensible and latent heat. Sensible heat is transferred by the processes of conduction and convection. Conduction transfers energy within a substance and convection transfers energy through the vertical movement of the heated substance. Latent heat is the transfer of energy by transforming the substance itself. As you recall, water has the ability to exist as liquid, gas or solid. The transformation from liquid to gas is called evaporation. The reverse process is from gas to liquid is called condensation. From liquid to solid is known as solidification. Freezing, and from solid to liquid, fusion, melting. Water can also be transformed directly from solid to gas, sublimation, or the reverse through a process called deposition. We will see these various processes in the formation of clouds. Clouds are formed when air contains as much water vapor gas as it can hold. This is called the saturation point, and it can be reached in two ways. First, moisture accumulated until it reaches the maximum amount the volume of air can hold. The other method reduces the temperature of the moisture filled air, which in turn lowers the amount of moisture it can contain. Saturation therefore is reached through evaporation and condensation. Respectively, when saturation occurs, moisture becomes visible water droplets in the form of fog and cloud. It should be noted that condensation by itself does not cause precipitation, rain, snow, sleet, hail. The moisture in cloud must become heavy enough to succumb to gravity and return to Earth's surface. This occurs through two processes. In cold clouds, ice crystals and water droplets exist side by side. Due to an imbalance of water vapor pressure, the water droplets transfer to the ice crystal The crystals eventually grow heavy enough to fall to earth. In the second process, water droplets in warm clouds collide and change their electric charge. Droplets of unlike charge attract one another and merge, thereby growing until they have sufficient weight to fall. There is no difference between fog and cloud other than altitude. Fog is defined as a visible moisture that begins at a height lower than 50 feet. If the visible moisture begins at or above 50 feet, it is called a cloud. Two common type of fog are called radiation fog and advection fog. Radiation fog forms during the night as the Earth's surface cools and the air immediately above it cools in turn by conduction. If the air is moist enough, the cooling causes it to reach saturation and visible water droplets form. We often call this type of fog ground fog because it lies so close to the surface. Advection fog forms when warm moist air moves over a colder surface. Advection means to move horizontally. A perfect example is on the west coast of continent. Prevailing westerly winds move moist air from over a warm ocean area to over the colder waters of the coast. Fog forms and is carried by the westerly over the land. Is cloud a gas, solid or liquid? Clouds are actually a combination of solids, liquids and gases. Most of the space in a cloud is just regular air that is interspersed with teeny droplets of liquid water, ice crystals and dust particles. There are numerous types of clouds at various different altitudes, but their compositions are largely the same. Is cloud a hydrogen? The molecular cloud. A molecular cloud is an interstellar cloud of gas and dust in which molecules can form. The most common of which is hydrogen H2. The Hubble Space Telescope has provided us with images of numerous young solar mass stars forming in giant molecular clouds such as the Eagle and Orion Nebula. How do clouds form? NASA. What are clouds? Grade 5 to 8. NASA. Clouds form when an area of air becomes cooler until the water vapor there condenses to liquid form. At that point, the air is said to be saturated with water vapor. The air where the clouds form must be cool enough for the water vapor to condense. 13 April 2011. Why does NASA study clouds? Water clouds. Grade K to 4 NASA. Studying clouds helps NASA better understand Earth's weather. NASA uses satellites in space to study clouds. NASA also studies clouds on other planets. Mars has clouds that are like the clouds on Earth. 3 October 2023. How are clouds named? Most of our names for clouds come from Latin and are usually a combination of the following prefixes and suffixes: stratus, strato, flat, layered and smooth; cumulus, cumulo, heaped up; puffy, like cauliflower; cirrus, zero, high up, wispy. Frozen water, snow seen in soil, is in both hemispheres, eyes and the eye. Is in both hemispheres, eyes only eye. Frozen water, snow seen in soil, is in both hemispheres, is in the eye. Is in both hemispheres, eyes only eye. Southern hemisphere, water. Northern hemisphere, soily rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Southern hemisphere, water. Northern hemisphere, soil or rocky. Both hemispheres cool every moment. Becomes the story of the snow. Becomes the story of the snow. Frozen water, snow seen in soil, is in both hemispheres, eyes only eyes. Is in both hemispheres, eyes only eyes. Frozen water, snow seen in soil, is in both hemispheres, eyes only eyes. Is in both hemispheres, eyes only eyes. And there are clouds in the air, atmosphere of snow even in the clouds. Falling clouds became rain. Snowfall drop by drop water. Snowfall drop by drop water. And there are clouds in the air. Atmosphere of snow even in the clouds. Falling clouds become rain. Snowfall drop by drop water. Snowfall drop by drop water. Frozen water, snow seen in soil, is in both hemispheres, eyes only eyes. Is in both hemispheres, eyes only eyes. Frozen water, snow seen in soil, is in both hemispheres, eyes only eyes. Is in both hemispheres, eyes only eyes. Snow and dust particles remain in the air and wave every moment. And finally, it also becomes the shape of a cloud. The biggest surprise is that even in the clouds, crystalline ice grows. Ice takes the shape of a rock in sea water. We have seen the proof of this in Titanic filmmaker James Cameron's movie. How far into the depth of the ocean can this ice shelf extend? Ice shelf. Wikipedia, https://wikipedia.organization, wiki ice shelf. An ice shelf is a large floating platform of ice that forms where a glacier or ice sheet flows down to a coastline and onto the ocean surface. Ice shelves are found in Antarctica and the Arctic, Greenland, northern Canada and the Russian Arctic. The boundary between the floating ice shelf and the anchor ice resting on bedrock that feeds it is the grounding line. The thickness of ice shelf can range from about 100 meter 330 feet to 1000 meter 3300 feet. The world's largest ice shelves are the Ross ice shelf and the Filkner Ronne ice shelf in Antarctica. When a large piece of an ice shelf breaks off, this can lead to the formation of an iceberg, which is a piece of fresh water ice more than 15 meter long. This process is also called ice calving. The movement of ice shelves is principally driven by gravity induced pressure from the grounded ice. The flow continually moves ice from the grounding line to the seaward from on the shelf. Typically, a shelf front will extend forward for years or decades between major calving events. Calving is the sudden release and breaking away of a mass of ice from a glacier. Iceberg, ice front, ice shell or crevasse. Snow accumulation on the upper surface and melting from the lower surface are also important to the mass balance of an ice shelf. Ice may also accrete onto the underside of the shelf. The effects of climate change are visible in the changes of the cryosphere, such as reduction in sea ice and ice sheets and disruption of ice shelves. In the last several decades, glaciologists have observed consistent decreases in ice shelf extent through melt. Calving and complete disintegration of some shelves. Well studied examples include disruptions of the Hawaii ice shelf, Larsen ice shelf, Filkner Ronne ice shelf, all three in the Antarctic, and the disruption of the Ellesmere ice shelf in the Arctic. How deep is the ice shelf? US NSF OPP ANT ice sheet. At its thickest point the ice sheet is 4,776 meters deep. It averages 2,160 meters thick, making Antarctica the highest continent. This ice is 90% of all the world's ice and 70% of all the world's fresh water. National Geographic Society, https www.nationalgeographic organization encyclopedia, 10 November 2023. An ice sheet is a mass of glacial ice more than 50,000 square kilometers, 19,000 square miles. Ice sheets contain about 99% of the fresh water on Earth and are sometimes called continental glaciers. As ice sheets extend to the coast and over the ocean, they become ice shelves. A mass of glacial ice covering less area than an ice sheet is called an ice cap. A series of connected ice caps is called an ice field. Making up ice fields, ice caps, and eventually ice sheets are individual glaciers. Today there are only two ice sheets in the world: the Antarctic ice sheet and the Greenland ice sheet. During the last glacial period, however, much of Earth was covered by ice sheets. Antarctic ice sheet, Wikipedia, https enwikipedia.organization wiki Antarctic ice sheet. In East Antarctica, the ice sheet resides on a major land mass, while in West Antarctica the bed can extend to more than 2,500 meters below sea level. What causes an ice shelf to increase in size? Ice shelves grow when they gain ice from land and occasionally sunk. When icebergs curve off their edges. This give and take maintains a kind of dynamic stability if climate conditions are relatively stable. Is Antarctica losing or gaining ice? Key takeaway: Antarctica is losing ice mass, melting at an average rate of about 150 billion tons per year, and Greenland is losing about 270 billion tons per year, adding to sea level rise. Friends, the height of the sea is increasing day by day. If we don't think differently now, tomorrow perhaps horror will be knocking at us. Well, I can say that it is your job to think. Well, my attempt was to write a lot about aquatic ice, so I wrote. Now think for yourself whether this is useful or not. Till then, allow me to take our story forward by writing living circles. Thanks, friends.